So in the stoichiometry we just did, we got this balanced equation. And what I want to do now is to take this balanced equation, and from this balanced equation, write a complete Ionic equation. A complete Ionic equation just breaks up all the ions that form ions. If you remember from the solutions unit, we said that ionic compounds that dissolve get solvated by the water. Okay, they get split up into separate ions. So the only things that actually split up in a complete Ionic equation are those ionic or acid compounds that are aqueous. If it's not aqueous, it doesn't split up, okay? Because it's going to be a solid. It's going to sit on the bottom. It's not really dissolved in the water. This is aqueous. It's ionic. It splits up. Now, there's one silver ion in the formula, but this 6 out in front means overall we have 6 silver ions. So we're going to show it that way. 6 silver ions, which are aqueous, okay, because they've been solvated. They're dissolved in the water. There are also 6 chloride ions. And here, this is aqueous, and it's ionic, so we have 2 aluminums there. We said aluminum has a 3+ charge. When we balanced this, we said that. And then we've got 3 sulfate ions here, okay? And sulfates have a 2 negative charge. All right? Now this is not going to break up. It's a solid. It doesn't dissolve. So we're not going to do anything with that. We just write it exactly the way it appears. 3Ag2SO4 and make it solid. Then we have 2 aluminums here. This coefficient 2 applies to everything. And we have 3 chloride ions in the formula times that 2. That's 6 chloride ions. Okay? And that is a complete Ionic equation. Okay? And to write the net Ionic equation, we're just going to leave out anything that stays the same. We're only going to keep the things that change. Okay? The things that are changing here are in the game. The ones that aren't changing, they aren't doing anything. They're sitting on the sidelines. They're just watching things happen. Okay? So these things that don't change are called spectator ions because they're sitting on the sidelines watching. So here's a silver ion. 6 of these silver ions. Over on this side, this is silver, but it's not an ion, or not dissolved in water anyway. It's not a separate ion. So this is changing to this. This is aqueous and that's solid. Those are not the same thing, so we're going to keep that. Now here are 6 chloride ions, and here are 6 chloride ions. They are separate. They're dissolved in water. That's exactly the same. They're spectators. We're going to leave them out. Here's 2 aluminum ions. It has a charge. It's aqueous. Same thing here. We're going to leave those out. They're just standing around watching. They're not participating in the game. Here's a sulfate ion. It is 3 separate sulfate ions. They have the charge. They're aqueous. That's not what I have here. This sulfate is part of a solid. That's changing. We're going to keep that. And this is a net Ionic equation.